Okay, welcome to the overview video on Cogulator. Today we're going to talk a little bit about what Cogulator is and how you can use it in your work. But before we get into any of that, let's go ahead and install Cogulator. So to do that, you can go to cogulator.io, then select the Downloads tab, and select either Windows or Mac, depending on what platform you're running. Once you download Cogulator, if you're running a MITRE Windows machine, you're probably going to have to unblock it from Windows Defender. The good news is doing that is fairly simple. Go ahead and download the file for Windows. Right-click on the file once you get it. Go into Properties, and then in Properties, go to the General tab. In the bottom right of the General tab, you'll see an option to unblock. Select that, and you should be good to go. All right, so let's talk a little bit about what Cogulator is. Cogulator is a cognitive calculator. More generally, it's a human performance model. Human performance models are used to estimate human performance when they're interacting with some tool or put into some new procedure. So that's probably still pretty fuzzy. Let's talk a little bit about exactly how Cogulator works, and then that'll tell you a lot more about what Cogulator does. So in order to build a model in Cogulator, we're going to enter a bunch of task steps. Cogulator will take those task steps and give you as outputs efficiency and mental workload estimates. So it'll tell you about how efficient the interface is, that is how quickly it is to do some task using the interface, or if there's no interface per se, some new procedure, whatever. And it'll give you some idea of how mentally difficult this interface will be for the user in their work. So we're going to talk about task efficiency and mental workload some more in a minute, but let's start breaking down what a task is exactly in Cogulator and what we mean by task steps. All right, so let's talk a little bit about what a task is. In Cogulator, one way to think about a task is in terms of a time scale. So something that takes a few seconds to a few minutes is generally a good candidate for modeling in Cogulator. If it takes 10 or 15 minutes, can you model in Cogulator? Sure. It's getting on the long side though. If it takes 500 milliseconds, can you model in Cogulator? Sure, but it's getting on the short side. Generally, we're looking for something that takes a few minutes to a few seconds. So let's think of an example of a pilot flying from one airport to another. The pilot's task in that case is to safely fly the aircraft from point A to point B. But of course, that take an hour or several hours. Typically, that's going to be much too long to look at in Cogulator, a full flight. So one thing we could do is break that down into smaller sections like phases of flight. So taxiing out to the runway, taking off, what we call the departure phase, on the en route, arrival, approach, landing, and then taxiing back to your gate or wherever. Breaking those down in those smaller sections, now we're getting something closer that we could model in Cogulator. Maybe still not quite there. We could, for example, model the entire taxi phase in Cogulator. That's probably not something we want to do. But consider, say, setting the flaps. So in the approach and landing phase, I need to manage my flaps. That's an excellent candidate for Cogulator. We can model the pilot going through the decision process to say, okay, now's the time I need to put some more flaps in. We can model the pilot determining how much and reaching for the flap handle and setting the flaps. And then we can model the pilot verifying that the flaps are in the correct position. Now, even better, if you have a comparison you want to make. So let's say you have some new whiz-bang idea for how to set flaps with a touchscreen device. We could do a model of using your touchscreen device. We do a model of setting the flaps the old-fashioned way with a physical handle or electric switch, and see, okay, which one of these takes longer, which one seems to require more time to looking down, and flying, we want to spend as much time as possible looking out the window. Which of these seems to increase mental load? It seems more mentally difficult, if any. So like I said, when you've broken it down to this task that takes a minute, maybe less, maybe a little more depending on the situation, but probably less. Now, and you've got these two comparisons, That's exactly the kind of thing you want to do in Cogulator. And of course, it's not limited to flying. Most models that you see in Cogulator have something to do with some kind of computer interaction. So doing something on an app on a phone, or working on your desktop computer or laptop, whatever, some kind of human-computer action. But it's not limited to just human-computer action. Like I said, you can model setting of flaps in an aircraft. You can model tuning a radio in your car, or dialing a phone number via voice, say, versus manually by hand. Hopefully you're not doing that while you're driving. You can model a surgeon during an operation doing various tasks. So there's a wide variety of things that Cogulator can be and has been used for in terms of modeling. But generally we're looking for some sort of task that lasts from a few seconds to a few minutes. And again, that can happen across a wide variety of domains. So how do we get a task in the Cogulator? Well, we do that by describing the task steps. And to describe the task steps, we use something called GOMS. If you have a human factors background, you may be familiar with GOMS, and you know there's a bunch of different variants. We use GOMS in Cogulator as a method for entering the task steps so that Cogulator can understand what the task is and then give you some estimates about efficiency and mental workload. If you're not familiar with GOMS, GOMS stands for Goals, Operators, Methods, and Selection Rules. The key part really for understanding what it is that Cogulator does and how GOMS enables it are operators. Operators are key words. So you can imagine that GOMS allows us kind of a formal method for describing a task, like a recipe. It's a formal method for building a recipe for completing some task. However, each step of that recipe must have a key word in it. We call those keywords operators. Now, operators are important in GOMS because they do two things. One, a key word, an operator, tells us something about the mental resource used, and two, there's a task time associated with it. So let's think about a very, very simple model in GOMS. Look, point, verify, and click. This is a model of using a desktop computer or a laptop with a mouse to point and click on something on the screen. So again, that's look at the target, whatever I'm trying to click on, point to it with the mouse. I'm going to verify my mouse is over the target, and then click on it. Okay. Look, point, verify, click. Very simple model. Each of those four keywords are operators in GOMS. If we look at the point operator, for example, it's got, again, those two components. There's a motor processor component. We know that we use our hands to use the mouse, and that's important. The Cogulator needs to know what's going on with the perceptual system, cognitive system, and motor system in order to properly model your task. And two, it has a task time associated with it. So by taking those two components, both the cognitive, perceptual, or motor aspect of it and the task time associated with the operator, Cogulator can figure out mental workload and task efficiency, how long it's going to take to do this task. Now I should mention that GOMS is not programming. You don't have to program to build a model in Cogulator. It's just a formal syntax for representing these task steps. It's relatively easy to learn, and most folks can pick up these things within an hour or two. And the good news is that in Cogulator, there are some methods for automatically building the GOMS syntax, as well as some methods for pulling pre-built methods, like for pointing and clicking or scrolling on something on an iPhone or Android device touchscreen, etc., etc. So, long story short, you're not going to have any problem learning the GOMS syntax that you need to use in Cogulator. The only other thing I want to mention about GOMS and Cogulator is we do have some enhancements, so it's not all just traditional GOMS. There's a few things we've done so that we can model mental workload in Cogulator, particularly working memory load, and we'll discuss those in a later video. Now let's talk about workload and efficiency. So we talked about the task steps that go in the Cogulator, and then the outputs are efficiency and workload. Efficiency is just how long is it going to take me to complete this task using this interface or during this procedure or whatever. And Cogulator makes those estimates in seconds. It's fairly straightforward. Mental workload is how difficult is this task going to be? How hard is this interface going to make me work? Or again, how difficult is this procedure going to be? To do that, we go back to those working memory adjustments that we have to GOMS. Working memory is how workload estimates are made in Cogulator. And we provide both a working memory load estimate, that is how much information am I going to be juggling while I complete the task using some interface or completing some new procedure. And then subjectively, about what would somebody rate this workload on a scale of 1 to 10. That is, Cogulator looks at the working memory load and based on some prior research makes an estimate based on juggling this much information. A person would typically estimate the workload on a scale of 1 to 10 to be 7 or 3 or 4 or whatever. All right, let's end this video with a few rules of thumb you can use to determine whether or not a task is really something that you should or could be modeling in Cogulator. The first rule of thumb is that the task involves some sort of interface. It doesn't have to be a computer interface. It can be, like we said, a flat panel in an aircraft, a physical thing that you interact with. It does not have to be an iPhone or a laptop or desktop. But you generally need some sort of interface that's a central component of the task. 2, the person is familiar with that interface, whatever the interface may be. They're not searching for the flat panel in the cockpit, or if they're trying to save a document in Word, this is not their first time using Word and they're trying to figure out where in the menu do I find File, Save. You know that you click File, Save, or Control S, or however you save a document. So the user is familiar and experienced with that interface. Okay. The third thing is that the task is fairly well structured, and that goes back to familiarity. This is not a task where somebody is doing creative problem solving. The first time they've encountered the problem and they're trying to figure out how to solve it. Generally, any problem solving is based on experience, not on, again, trying to take apart a problem in real time. So if we look at a driver who's coming up on a car in front of them, there's not a lot of thought process about how exactly should I handle this situation. Do I go through and pass, or do I press the brake? There's a decision process, but it's not what we would call creative decision making, where I've never experienced this before. I've experienced it very few times, and I'm just trying to reason through what I might do. It's reactive and what we call overlearned. And the last rule of thumb is that your interface is an idea or an inaccessible implementation. What do I mean by that? Well, your interface is an idea, that is, it doesn't exist in the real world yet. So you may want to make some design decisions based on the kind of quantitative data Cogulator can provide before you actually build the interface. So that's a great candidate for using Cogulator. The other is an inaccessible implementation. By that we mean you'd like to do a study with the real interface, but either the interface is something you can't access, or the population that you need to test the interface, you can't get access to. So long story short, you can't do a HITL either because you can't get to the interface, or you can't recruit the population. Maybe they're a very hard population to get to, maybe it's too expensive to conduct a HITL, whatever. Then you're in a situation where Cogulator is a great alternative to doing a HITL or the like. And you can get a lot of, again, good quantitative information from Cogulator in terms of efficiency and mental workload. There are other great reasons to use Cogulator. For example, the fact that it provides objective workload estimates is pretty nice. And it's nice to compare those to subjective workload estimates that your user may give you in some sort of study or usability evaluation. And of course, there's many other reasons to use Cogulator, and there's plenty of reasons not to use Cogulator. It's certainly not a tool that's meant to fit every single situation. And you notice in the things we've talked about today, we haven't, for example, discussed clutter on the interface, or perceptual flow through the interface, or the aesthetics of the interface. It's because Cogulator is useless for evaluating any of those things. Again, Cogulator is a tool, and it's a tool designed for a specific purpose. And so if your purposes align with the tool, then we're in great shape, and Cogulator would be a good candidate for you. In other videos, we'll go through and talk a little bit more about exactly how to model in GOMS. We'll talk about doing working memory load. We'll walk you through the interface and the like. but this will give you at least a good introduction to what Cogulator is and generally how it works.